Press the bell icon and never miss a video from Flip Academy. Sir Isaac Newton formulated a very important law on gravity, which is called the inverse law of gravitation. Now, according to this law, every object attracts other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This law is also called inverse square law. So, according to the use of inverse and square in this expression, the name is justified. Now, let's see. There are two objects A and B of masses m1 and m2 individually, such that the distance between them is small r. Now, as it was stated that between every object there exists the force of attraction, and this force of attraction is towards the center of two objects. Now, according to the gravitation law, the first point came is that the force is directly proportional to product of their masses. That is, F is directly proportional to m1 multiplied by m2. The second point is that force is inversely proportional to the square of the distance between them. That is, F is inversely proportional to r square. On combining the above two expressions, we will get that F is directly proportional to m1 into m2 upon r square. Now let's remove the proportionality sign, and for that we require a constant. And the constant is represented by capital G, which is also called a universal gravitation constant, or it is a number that gives us the strength of gravity. Now let's do cross multiplication. On the left hand side of the equation, it turns to F multiplied by r square, and RHS turn to G, which is a gravitation constant, multiplied by m1 into m2. Now on rearranging the equation such that G becomes the subject of the formula. So G gives you F r square upon m1 into m2. Now let's see the SI unit of G, which is a gravitation constant. So G is given by the unit. For force, the unit is Newton. For R, which is a distance, the unit is meter, so it becomes meter square. Upon for m1 into m2, which are the masses of the object. So it is represented in kg, as m1 and m2 both are equal, so it becomes kg square. So we will get the unit of G, which is Newton meter square per kg square. Now let's see the value of this constant. The value of G is given by 6.673 into 10 raised to the power minus 11, and the unit we have already calculated, that is Newton meter square per kg square. So this is the mathematical expression of universal law of gravitation. After that, the Newton concluded that all objects in the universe attract each other. So now let's see the different value of gravitational force for different mass objects. In the first case, let us consider the two objects A and B with masses m1 and m2. The mass m1 and m2 are 1 kg each, and the distance between them is 1 meter, which is the value of r. Now, the formula for the gravitational force is given by F is equals to G m1 into m2 upon r square, where G has the particular value, that is 6.6 into 10 raised to the power minus 11, multiplied by m1 and m2. Both have a mass 1 kg, so it is multiplied by 1 upon r square. R is given to us, that is 1 meter, so it becomes 1 square. That is, the gravitational force is equals to the gravitational constant, that is 6.67 into 10 raised to the power minus 11 Newton. So we can see from the above expression that if the masses are small enough, then the force of gravity between them is also very less. In the second case, again there are two objects. One is the ball of mass 1 kg and the other is the earth. And we all know that the mass of the earth is 6 into 10 raised to the power 24 kg. Now let's again use the universal law of gravitation, where the gravitational force F is equals to G m1 m2 upon r square. Now, G is known to us, that is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. The radius of the earth is given to us, which is 6.4 into 10 raised to the power 3 kilometer. All these value, that is the radius of the earth and mass of the earth, is a constant value and it is calculated and thus the value is already given to us. Now, if the radius of the earth, which is in kilometer, and we have to convert it into meter, so we have to multiply 6.4 into 10 raised to the power 3 by 10 raised to the power 3. So it will become 6.4 into 10 raised to the power 6 meter. So now let's put all these values in the formula. On putting the value and rearranging it and then numerically just solve the value, you will get F is equals to 9.8 Newton, which is a very large force applied by the earth on the ball of mass 1 kg. So now let's draw the conclusion. The first is that for larger masses, large gravitational force exists. The second is for smaller masses, less gravitational force exists. Now let's summarize what we have studied till now. The first is that the universal law of gravitation is given by F is equals to G m1 into m2 upon r square. The second is that the unit of gravitation is Newton meter square per kg square. The third is that the numerical value of gravitation constant is equals to 6.6 into 10 raised to the power minus 11 Newton meter square per kg square. And the fourth is when there are objects of larger masses, then gravitational force of attraction between them is also very large. And the fifth is that the gravitational force exists between every object on this earth, but they cannot attract each other due to very small force of attraction.